Good afternoon. My name is Hunter Manning, and this is my submission for Lab 2, Charge Tapes Revisited. Before we get started, I'd like to briefly discuss the contents of this experiment. First, I will introduce this experiment. I will then introduce some fundamental concepts that are at the foundation of this. I will then identify the initial conditions, assumptions made in the lab, and identify the system and the surroundings. Then I'll dive into my computational model via my glow script analysis. After this, I will discuss the results, and I will finally wrap up the report with discussion and conclusion while answering the assigned what if and why does it matter questions. Not diving into our introduction, the purpose of this lab was to produce a computational model using the values calculated from Lab 1. In this lab, however, the charge will be evenly distributed across the length of the tape. In this lab, we will be comparing the differences between charges of tape in Lab 1, where we consider it to be a point charge, versus the charge of the tape in Lab 2, where we would distribute the charge across the entire length of the tape. To determine the charge of the tape, data was collected experimentally in lab. In this lab, I will be using GlowScript to produce a computational model that shows us how a charged piece of tape looks and interacts. Briefly touching on the results of this experiment, in Lab 1 we determined the charge of the piece of tape to be 1.06 times 10 to the negative 8 coulombs. In this lab, however, the charge was found to be 6.2 times 10 to the negative 8 coulombs. Now I'd like to take a moment to discuss some of the fundamental principles behind this lab. First, let's talk about the Coulomb's law of electric force. This relates the electric force acting on an object to the product of the charge of the object times its electric field. This equation can be further manipulated to equal K times Q1 times Q2 over R squared times R hat. In this equation, K is equal to 9 times 10 to the 9 Newton meter squared over Coulomb squared. The second fundamental concept in this lab is gravitational force. This force is equal to the product of the mass of the object times the gravitational acceleration constant, and it is important to note that this force is in the negative y direction. The final fundamental principle in this lab is Newton's second law. This law relates to the net force acting on an object to the product of the object's mass times its acceleration. One final thing that I believe is important to note is that the values of the electric force, the electric field, the net force, the force of gravity, and R hat and A are all vector quantities, which means they have both magnitude and direction. Now I'd like to take a moment to identify the initial conditions, the assumptions made in the lab, and the system and the surroundings. First up, the initial conditions. The tape mass was found to be 2 times 10 to the negative 4 kilograms. Tape length was found to be 0.2 meters, and the distance between the two tapes was found to be 0.006 meters. And all of these values were found in Lab 1. Further, the system can be identified as the top tape, the surroundings can be identified as the bottom tape plus the earth, and the assumptions made in this lab are as follows. Negligible air resistance, each U-tape has about the same amount of charge and equal distribution, and finally, uniform charge distribution across the length of the tape. Moving on to the computational model, on the left is the code that accounts for the initial conditions that I discussed earlier on the report. On the right, you can see the code that sets up my electric field calculation using Coulomb's law. Below that is the code that creates a line of charge. On this part of the code, I did not make any changes to this based on the instructions given in the starter code. Continuing with the GlowScript analysis, at the very top of this slide, you can see the top code that establishes the top and bottom tapes. The top tape takes the color red, while the bottom tape takes the color blue. Below this is the electric field and electric force calculations for the top tape and the bottom tape. Finally, at the very bottom is the final code that creates the arrows that represent the net electric force on the top tape and the gravitational force on the top tape. And if you'd like to see any more details on my GlowScript code, I'll have it linked there on the perusal. Moving on to the results of this experiment, the magnitude of the electric force was found to be 1.94 times 10 to the negative 3 newtons. The magnitude of the gravitational force was found to be 1.96 times 10 to the negative 3 newtons. The charge of the tape was found to be 6.2 times 10 to the negative 8 coulombs. And finally, some potential sources of error include rounding errors, inconsistent measurements in lab, and my touching the tape during lab. Moving on to the what if question. The line charge value was significantly greater than the point charge value from Lab 1. Line charge value was found to be 6.2 times 10 to the negative 8 coulombs, while the point charge value was found to be 1.06 times 10 to the negative 8 coulombs. In the line charge model, there are many charges distributed across the length of the tape, not just a single point charge, which could be the reason for the large difference in charge. And finally, the why question. Why do these estimates differ? This is because the different values could be from different methods in calculating the charge. The line charge method is closer to the real value as it splits the tape into small sections that can be summed and added together to find the total net charge.